The population of Mexico, as estimated every 5 years since 1960, is shown in the table. Use the average rate of change to generate a function model p of x for the population of Mexico x years after 1960. Then determine the accuracy of the function model by comparing the function value to data values for the years 1970, 1990, and 2010. Okay, so first let's find the average rate of change. And so to do that, then we need to take our dependent variable, which in this case would be the population in millions here, and we'll take the difference of the last and the first values. So 127 minus 38 and 68 hundredths, and then we'll divide it by the difference of the last and first x values. But just notice that the x variable is actually years after 1960, and so it's not actually the year, it's the years after 1960. And so, for example, in 1960, that would be 0 years after 1960, since it's the same year. 1965 would be 5 years after 1960. 1970 would be 10 years, and so on. And so those will actually be the x values. And so then 2015 is actually 55 years after 1960. And so that will be our x value. So we'll take on the bottom 55 minus 0. So let's go ahead and write that out. And so what I did in the calculator is I just plugged in the numerator there in parentheses, and then divided by the denominator, making sure to put parentheses around that as well. And so then we get a big decimal, which is 1.6058181, and it keeps going. And so let's go ahead and just round to the nearest thousandth. And so that would be approximately then 1 and 606 thousandths, since that 8 behind the 5 would round up that 5. And so then that will be our rate of change in our function. So for p of x, that will equal 1 and 606 thousandths x, and then plus the y-intercept. And so the y-intercept is when x is 0. So when x is 0 in 1960, then we see our population here is 38 and 68 hundredths. And so now we have our function model, and we want to see, is this actually going to be representative of the real population those years? And so we're going to check 3 years, 1970, 1990, and 2010. Okay, so for 1970, then remember that's when x would be 10. And so we're just going to plug in 10 to our function. And plugging that into the calculator, then we get 54 and 74 hundredths. And so let's go ahead and compare that to what's in our table. So our table is actually 52 and 99 hundredths. So we're a little bit high using our function model. So let's go ahead and try 1990. So that would be 30 years after 1960. So that's p of 30. And there we get 86 and 86 hundredths. And then let's compare that to the actual value in the table, where it's 86 and 8 hundredths. So again, a little bit higher than the actual population that year. For 2010, that will be p of 50, since that's 50 years after 1960. And there we get 118 and 98 hundredths. So then we'll compare in the table, we see it's 117 and 9 tenths. So again, it's a little bit high there as well. And so our function model is pretty close, but it does estimate high in every single case so far. And so we can conclude there that this could be still a useful function model for population. Just in general, it's probably a better thing to overestimate the population than underestimate. For example, with a country doing national security or infrastructure, you want to make sure that you have enough security, or you're accounting for as many people as there are. It would be way worse to underestimate in terms of population. And so that could be a benefit to this function. But now that we have gone ahead and assessed that, let's go ahead and summarize our answer. P of x equals 1 and 606 thousandths x plus 38 and 68 hundredths. For 1970, P of 10 equals 54 and 74 hundredths, and the data set value is 52 and 99 hundredths. For 1990, P of 30 equals 86 and 86 hundredths, and the data set value is 86 and 8 hundredths. For 2010, P of 50 equals 118 and 98 hundredths, and the data set value is 117 and 9 tenths. It appears that P of x slightly overestimates the population of Mexico x years after 1960. When planning for national services and infrastructure, a model that overestimates population is more useful than a model that underestimates. If the model had underestimated population, it is possible that the growth of the population would have overwhelmed the existing infrastructure, and there would not have been enough national services for the needs of the population.